Oh, hello, Honors Math 1s at Shasta High School. This is Mr. Roberts, and this is a look at the Chapter 11 Study Team Test. Um, so, this first question, I think one of the things that helped me think about this better was to really focus in on what my variable x was and what it represented. So let's take a look at this problem together. It says, after college, your sister gets a job with a starting salary of $35,500. That's an annual salary. And her first day on the job is January 1st, 2018. That's convenient in terms of the problem. You have a cousin working at the same corporation, but he was hired 3 years before your sister. Your sister's contract states that she will receive a pay raise of 7% each year that she remains with the company. Your cousin tells you that he began at $40,000 and has been guaranteed a 5% raise each year. All right, so the practicality of this, I don't know any businesses that work this way. I think usually you have an annual review, and they're looking at like how well are you performing, and then you make the case, I'm worth more money, or and this is how much more I want, or this is what I think my pay increase worth. So it's never just like, hey, we're just going to keep giving you 7% each year. But of course, we're in a math class and we're trying to contrive a way to control the world and come up with an equation here that we can work with. So the parameters here, we've definitely been guided into an exponential growth pattern. One is a 7% each year, and one's a 5% growth rate. A asks us to make a table first, and I think I know why I asked that question first, because I wanted you to think about, hey, here's the 35,500 plus 7%, and then that number plus 7%. But I'm actually going to start with the formulas, and then we'll use that to fill in the table. So Part B, let's start with Part B. It says, Part B, write two formulas you could use to determine your sister's and your cousin's salary given the number of years that your sister has worked at the company. So this is the thing that I think is most important. The number of years that your sister has worked at the company. And I'm sorry that's too dark of a highlighter. Let me make this a color that we can see. Number of years that your sister has worked at the company. So that's exactly what I want X to be. I'm going to let X be the number of years that the sister has worked at the company. So let's think about her equation first. So I'm just going to say, for simplicity, Y is the amount of money that she currently gets paid each year. And it started at the 0th year of $35,500, and she's guaranteed a 7% increase, right? A raise of 7% each year. So if I've got a 7% increase, my multiplier is 1.07. And then I'm going to just raise that to the x power. So that's the number of years that I've been working, is my exponent to the x power. Now, of course, the reason why this is 1.07 is because it's a raise. If for some reason something was depreciating or decreasing by 7% each year, my multiplier in that case would be 0.93, which would be 1 minus 0.07. Here I've got 1 plus 0.07. Okay, so this is the equation that represents your sister's annual salary given X, the number of years that she has worked at the company. Let's write the equation for your cousin. So that is Y equals, starting at $40,000. And then we're going to multiply here by 1.05. Now, remember, X represents the number of years that the sisters worked at the company, but your cousin has worked at this company longer. He's been there for 3 years before she came. So that means that if she's worked 2 years, he would have worked 5. If she's worked 7 years, if your sister's worked 7 years, the cousin would have been there for 10. So in general, what's happening, if X is the number of years that she has worked at the company, then X plus 3 is the number of years that he's worked at the company. Okay, so this is a very nice description of exactly what's happening here, of the growth. And at this point, I want to build out a table using my calculator. So I'm going to turn this on. Oh, look at it, it's all fresh here. I'm going to go to Y equals. And for the first equation, we're just going to do 35,500. And we're going to multiply that. Oops, I didn't do 35,500. We're going to multiply that times 1.07 raised to the x power. All right, there's your sister, that's y1, and then for the cousin, it's going to be 40,000, 40,000, and we'll times 1.05, and we'll raise that to the x plus 3 power, x plus 3 power. So we know, because of this higher interest rate, that eventually, right, the sister's going to overtake the salary of the cousin. It's just a matter of time because he's just getting 5% pay increases and she's getting 7% pay increases. So if I want to graph this, right, I could just hit graph and I see absolutely nothing. And the reason why I see nothing is because my x values are ranging from 0 to 10, and my y values are going from, or actually the x values are going from -10 to +10, and then y's are from -10 to 10. So this window is too small. Everything that I want to see isn't happening here. So I'm going to do a couple things. I'm just going to hit window, and I'm going to change my window using my understanding of this problem. So for example, I understand that I'm starting at year 0, so I'm just going to make my smallest x 0. And I'm going to run out, I don't know, to start with, I'm just going to I'll look at 20 years. I may need to look at more years, but I'm going to go from year 0 to year 20. The other thing that I need to do is, I don't care about negative dollars. I'm going to start, I'll start at $0, but honestly, their pay is starting at $35,000 or more, right? And then increasing from there. So actually, it probably would be better if I said, look, let's start at $20,000. So my Y minimum I care about is $20,000. And I know that, when she catches up, it's going to be higher than 40,000, right? So I might say, let's start at 80,000. I'll do it actually 90,000. So again, if Y is the amount of money, right, I'm going to be looking at values from 20,000 up to $90,000. So let's take a look at this graph now with this improved window. And you can see, okay, this is great. This is the sister, and now we see the cousin. And you can see just at the end there, we were seeing where they were starting to cross. And I think time is good. I just think that $90,000 isn't enough. So let's modify this window again. So instead of $90,000, I'm going to make this 110,000. 110, and then 1, 2, 3. And actually, looking at, I don't need to see the 20,000. I'm going to just kick this down to, I'll kick it up to 30,000. All right, so let's take a look at the graph now with that new window. Here we are. This is the sister starting at 35,500. Here's the cousin starting at 40,000. And you can see that the sister's salary is larger right here where these 2 points meet. So the question is, where is that point at? Well, before we answer that question, let's take a look at filling in the values for our table, right? So this table, we were supposed to come up with the first 5 values. So I'm going to say X is, of course, the number of years that the sister has been working at the company. And she's been working for 0, 1, 2, 3, 4, 5 years. And we'll go ahead and put sister here, S-I-S-T-E-R, and we'll put the cousin here, C-O-U-S-I-N. And I'm going to give these functions better names. I'm going to say that the sister's function is f of x, and then I'll call the cousin's function g of x. So this is just for me to keep track of them. So now if I come in and I look at the table on my calculator, I'll hit second table. You can see I'm starting at year 0. And what's nice is I've got all of these values here, right? So I'm just going to copy these into the table. So honestly, it feels like these equations to me are much more powerful than this table. To generate that table by hand would have been a lot of work, but having the equation here and having it generated for me Really simplified the process. So I've got the first 5 years there. Now, one of the things I can do on the calculator is I can go down and I can just say, here's years, right? And I'm looking for when the sister has a higher salary. In other words, when that Y1 or the second column here is larger than the second column. So you can see here at year 9, the sister's making 65,265, and the cousin's still above that. So I have to go out pretty far. Still haven't caught it. And then right here it happened, right? So at year 14, the sister was making 91,538,000 a year, and the cousin was making 91,681. Well, the following year, her salary is higher for the first time at year 15. She's now making 97,946,000, and then for the rest of this, oh geez, these things are growing crazy fast. Then I'm pretty sure this is not how it works, because if you look at from year 16 to 17, she was at 104,000. The next year she's at 112,000. That's like an $8,000 a year pay increase. And I'm thinking at this point, you're not only one of my most expensive employees, but every single year I have to pay you so much more. This is, if you could lock an employer into this scheme, yeah, it'd be a great way to have a crazy big salary. So let's go ahead and go back and look at our graph. So this is a little problematic, the sketching of this. Probably the thing that you want to do is just go through and look at these points and plot them as close as you can. You guys pointed out in class to me that I didn't quite leave enough room because it happens after year 14, between year 14 and 15. So when I plot it, it looks a little bit off. So this is my pretty pathetic attempt. I'm really unhappy with how the scale of this graph turned out, and how difficult it was to plot those points, because it's such a subtle change with 7% and 5% over that time that it was difficult for me to track what was going on. But this is my attempt at the graph. What I wanted to show you was how you're able to find intersects. I just want to review that with you when you've got a couple points. So one of the tools we talked about this chapter was, if you're trying to solve a system of equation, or solve an equation that you're not sure how to solve it, one of the tools we can have is just to figure out, look at the left hand and the right hand side as separate equations. That's not exactly what's happening here, because what's happening here is we have two different equations, right? One describes your sister's salary, one describes your cousin's salary, and we want to know when their x values are the same. So I can figure that out by, first of all, having it visible where those two lines meet on my graph, and then just asking my calculator to find the exact coordinates of that intersection. So if I press second and then calc, it's right here, CALC. It's on the same button that says trace and F4. When I do that, my calculator asks me a few questions. Whoops, I'm sorry, just a second, and calc. And I want to find where two curves are intersection. I want to find the intersection of two curves. So it's option number 5. Now, my calculator asks me, what are the curves where you want to find the intersection? It's possible that I could have more than two things graphed, and I want to find where two different particular ones intersect. So for this one, you can see I'm on this bottom curve, and it says first curve, and since I'm on it, I'm just going to go ahead and press enter. So I've selected that bottom curve as the first curve, and the only other curve I have on my screen right now is the second one. So I'm just going to hit enter for second curve. So now I have my two curves selected, and then it asks me, what do you think is a guess for where they intersect? So I'm just going to move my cursor kind of closer to that intersection point. It's probably advantageous if you're slightly to the left of where they actually intersect. But just right about here, I'm going to say, well, I think that's close enough. So where do they intersect? I press enter. My calculator says, well, when x is about 14.082596, right? There we go. So I know from looking at this that it's going to happen, after year 14, right? It's not going to happen at year 14, because they calculate the salaries then. So it's at the beginning of the year. These are not compounded quarterly or monthly. They're just compounded at the beginning of the year. So at the beginning of the 14th year, sister is making less because this didn't hit that number, but at the start of the next year, year 15, she'll be making more. And I can see this in my table as well. So if the question is, what value of x makes these true that are equal to each other, it's about 14.08. You can see the decimals there. And I can see this again on my table. If I go to the table and I go down to year 14, and there you go, at year 14, she's making less, and then at year 15, she's making more. So the answer is somewhere at the start of the 15th year, she will have a higher salary than the cousin. Year 14, she'll still have a slightly lower salary. So that's it for question number 1.